Hi everyone, my name is Amitesh, and in this video we're going to graph the function y equals log x in 5 minutes. So we'll recall what log is right from scratch and do the graph. So let's get into it. So we have the function y is equal to log of x. So here the log is to the base of e. So what does this mean exactly? What is log exactly? So log is, if I want to find log e of x, well basically I'm trying to fill in the blank in the following problem. I'm trying to figure out what do I have to power e by to get x. That blank there, in that equation over there, is what we call log e of x. So in other words, it's defined so that log e power log e of x is going to equal to x. That is the definition of log e x. Now with that in mind, we can quickly get a sense of what some values of log are. So for example, log e of e is what do you have to power e by to get e? Fill in the blank as in e power blank is equal to e. Well, the answer is going to be 1. E power 1 is equal to e. So log e of e is just going to equal to 1. Similarly, if I try to figure out what is log e of e to the something, it doesn't matter what the something is, the principle is the same, let's say e to the 10, then basically I'm asking what do I have to power e by to get e to the 10? So here I have to fill in the blank, e power something is equal to e to the 10, and that problem just solves itself. So we just get that 10 is the answer, and that is going to be log e of e to the 10. Now if you know log laws, you can figure this out yourself, but I'm just giving you an introduction without actually assuming any prior knowledge. So similarly, what we can do is we can take log e of e to the negative something, let's say negative 5. What is that going to be? So I want you to think about that quickly. It's going to be the solution to the fill in the blank problem. E power something should be e to the negative 5. So what should the something be? The something should just be negative 5. So log e of e to the negative 5 is going to be negative 5. Now that we've got a quick introduction to logs, let's get into graphing the log function. So the first step is to figure out what is the domain of the function. So basically, when can you find a solution to e to the something is equal to x? Well, e to the anything is always going to be a positive number. E to the 5 or e to the something positive is positive. And if you take something like e to the negative 5, it's going to equal to 1 over e to the 5, which is also going to be 1 over a positive number. So a quick overview of why e to the something is always positive, and so therefore you can only solve this fill in the blank problem when x is positive. So the domain of log is going to be all positive numbers. So here we can draw the graph of log. We've got the x-axis here, the y-axis here. The domain is going to be all positive x, so I'm going to write it as the domain is going to equal to the interval 0 infinity. These are all numbers between 0 and infinity, so all positive numbers. I've done videos on interval notation, check them out if you like, links down in the description. So here we've got that domain. Now how do we figure out what some values of log are? Well, here's the first point. When is log of something going to be 0? So is there an x-intercept? That's a good point when graphing a function. Is there an x-intercept? So let's quickly check that out. So here I'm going to sort of erase this. Well, an x-intercept would be log e of something is equal to 0. And that means, if you look at the fill in the blank problem, that means that e to the 0 is going to equal to x, right? So that log e of x is 0 means e to the 0 is x, which in other words means that x is equal to 1. So we already know that the x-intercept is when log is going to equal to 0. That's going to be at the number 1. We know that log e of e to the negative 5 is negative 5. Log e of e to the anything, so I say log e as in base e, log of anything, e to the negative 100 is going to be negative 100. And of course, e to the negative 100 is a very small number because it's 1 over e to the 100, right? E to the 100 is super big, 1 over e to the 100 is super small, but it's still positive. So the idea is that as we get smaller and smaller numbers, the value of log is going to get more and more negative. Log of e to the minus a million is minus a million. So you kind of see that the graph of log is going to steeply go down as we take positive values, and we're going to get some shape like that. And now the next point is that when you take log of e to the something big, like e to the 100, so log of e to the 10 is 10, log of e to the 100 is going to be, sorry, 100. So as your x value gets larger, your graph is going to keep going up like this. It's going to get bigger and bigger in y value. So another way of saying this in the language of calculus, I'm just going to draw this here, is limit x goes to 0 from the right hand side of log x is going to equal to negative infinity. So that means log approaches negative infinity as x approaches 0 as a small positive number, and limit x goes to infinity of log x is going to equal to infinity. So as x gets larger and larger, log of that gets larger and larger too. So that's the graph. This is what is called logarithmic growth. So it takes a very long time for log to become big. So for example, e to the 10 is a huge number, but log of e to the 10 is only 10. So this graph is kind of very steadily and slowly going up. It's a concept that's pretty important in calculus. Log grows slower than any polynomial, for example. But we'll talk about that in other videos. I hope you loved that video. 5-minute introduction to graphing log. I'm going to do a 5-minute math series. This is the first video I'm doing. I hope you liked it. Please like and subscribe. My goal is free and accessible math education worldwide so everyone can love and enjoy math. And I want to make it super fun, super accessible, and give you all you need to know, not just to love math, but also do well in any course you're doing in high school or college, or even just self-studying. Thank you so much, and I'm super excited to see you in the next video.